Good afternoon, everyone. Let us work problems on analytic function, that is construction of analytic function. Given the real part or the imaginary part, you have to construct an analytic function. Find the analytic function whose real part is given. Here, a real part is given. You have to find the imaginary part also. After finding the real part, using that, you have to find the imaginary part, because in the question we have hence find. Hence find implies using the result obtained after real part, you must obtain the imaginary part. First problem is e raised to x sin y. Here real part is given. Suppose f of z is u plus iv. The real part u is given. That is u is e raised to x sin y. So let f of z equals u plus iv be analytic. It is given that the function is analytic. For that, u is given, that is real part is given, and the v is not given, but u is given. So u is e raised to x sin y. Differentiate partially u with respect to x. Differentiate partially u with respect to x. That is e raised to x sin y, because the differentiation of u with respect to x keeping y constant. Differentiation of e raised to x is e raised to x. And the differentiation of sin y, that is constant, therefore keep it as it is. Next, delta u by delta y. You have to differentiate u with respect to y keeping x constant. So e raised to x, differentiation of sin y is cos y. We apply Milne-Thomson method. What is Milne-Thomson method? By putting x equals z, y equals 0 in f dash of z. For that we require f dash of z. So f dash of z is delta u by delta x plus I into delta v by delta x. It's a formula. Delta u by delta x plus I into delta v by delta x is f dash of z. Now we shall use the CR equation. See, in the CR equation, delta v by delta x is nothing but minus delta u by delta y. So in the CR equation, delta v by delta x is nothing but minus delta u by delta y, or delta u by delta y equals minus delta v by delta x. Using that, we have f dash of z equals delta u by delta x. We have replaced delta v by delta x by minus delta u by delta y. That is using Cauchy-Riemann equations. Next, what is delta u by delta x? That is e raised to x sin y. What is delta u by delta y? That is e raised to x cos y. So I will get e raised to x sin y minus I into e raised to x cos y. In the Milne-Thomson method, you have to put x equals z and y equals 0. If you put x equals z, so f dash of z equals e raised to z, y is 0, sin 0, minus I into e raised to z, because x is z, into cos 0. But sin 0 is 0, remember. Cos 0 is 1. You will get minus I e raised to z. This is f dash of z. If you know f dash of z, you can find f of z by integrating f dash of z with respect to z. So if you integrate both sides with respect to z, the integration of f dash of z is f of z equals minus I into integration of e raised to z is e raised to z. Integration of e raised to z is e raised to z plus some constant. So what we are required to find is find the analytic function. So what is that analytic function we have found now? Minus I e raised to z plus constant. Next, you have to find the imaginary part of this function. For that, put z equals x plus iy. So you will get minus I into e raised to x plus iy plus constant. So it is minus I into e raised to x into e raised to iy. But what is e raised to iy? E raised to iy is cos y plus I sin y, because e raised to I theta is cos theta plus I sin theta. That is Euler's formula, plus constant. Next, this is e raised to x into, take I inside. Take this minus I inside. You will get minus I into I is plus 1, remember, because minus I square minus I into I. If you take that inside, that becomes plus 1 into sine y, because I square is minus 1. Next, another term is minus I into cos y plus constant. Next, if you multiply this e raised to x sine y minus I e raised to x cos y plus constant can be written as I into c. This is because e raised to x sine y is the real part. Real part you cannot alter because given there. What is given there in the real part? E raised to x sine y. I, you cannot associate I here because e raised to x sine y is the real part, it is given. Therefore, you have to associate I with the constant. So therefore, constant can be written as I into c. Further, if you take I common there, you will get c minus e raised to x cos y. That is u plus I into c minus e raised to x cos y. It is of the form u plus iv. What is v? Imaginary part. So that v is c minus e raised to x cos y. So for this function e raised to x sin y, for the function e raised to x sin y, the function is what? Minus I e raised to z plus constant. And the imaginary part is what? Imaginary part is c minus e raised to x cos y. So here the given the real part is e raised to x sin y. So imaginary part is constant minus e raised to x cos y. This is how you can find the imaginary part and also the function using that CR equation and Milne-Thomson method. In the Milne-Thomson method, remember you have to put x equals z and y equals 0 in f dash of z. Take another problem. So what is the next problem? Real part is given. Real part is sin x cos hyperbolic y. So second problem is sin x cos hyperbolic y. This is the real part. Same procedure can be continued here. So let f of z equals u plus iv be analytic. What is real part? U sin x cos hyperbolic y. Find differentiation of u with respect to x partially. That is delta u by delta x is differentiation of sin x is cos x. Cos hyperbolic y is constant. Next, differentiation of u with respect to y is, that is sin x. Differentiation of cos hyperbolic y is sin hyperbolic y. Next, in the CR equation derivation, what we have is f dash of z equals delta u by delta x plus I into delta v by delta x. So this is delta u by delta x. Again, using CR equation, you can replace delta v by delta x by minus delta u by delta y using CR equations, that is. So which is equal to substitute the value of delta u by delta x, that is cos x, and cos hyperbolic y minus I delta u by delta y is sin x sin hyperbolic y. Next, use Milne-Thomson method. Put x equals z, y equals 0. You will get cos z cos hyperbolic 0 minus I into sin z sin hyperbolic 0. Cos hyperbolic 0 is 1, remember. This should be cos 0 equals 1 alla, cos hyperbolic 0 agbeku. Cos hyperbolic 0 equals 1 and sin hyperbolic 0 is 0. This is because cos hyperbolic 0 is nothing but cos hyperbolic x andre enandre, it is e raised to x plus e raised to minus x divided by 2. X here 0 substitute madidre. So therefore e raised to 0 1 plus e raised to minus 0, that is also 1. 1 plus 1 2 divided by 2, therefore it is 1. Adrinda cos hyperbolic 0 is 1. Sin hyperbolic 0 is 0. Remember this. Next, if you substitute there, you will get f dash of z equals cos z stable because cos hyperbolic 0 is 1, sin hyperbolic 0 is 0. F dash of z cos z integrate model. Integrating both sides with respect to z, we get f of z equals integration of cos z is sin z plus constant, because after integration, you will get constant of integration. Next, this is sin into x plus iy, z is x plus iy plus constant. Sin of a plus b formula is sin a cos b plus cos a sin b. Therefore, sin x cos iy plus cos x sin iy plus constant. Also, we have derived that cos iy is cos hyperbolic y. First class derive cos iy is cos hyperbolic y. So therefore sin x into cos hyperbolic y plus, remember, sin iy adu kuda I sin hyperbolic y. Note the difference there. Cos iy idre just cos hyperbolic y. Ade sin iy idre It is I sin hyperbolic y. Therefore, you will get I into cos x into sin hyperbolic y plus constant IC. Plus constant IC. This is sin x cos hyperbolic y. I term group ಮಾಡಿದ್ರೆ cos x sin hyperbolic y plus c. This is of the form u plus iv. U is sin x cos hyperbolic y. ಈ ಸಿನ ರಿಯಲ್ ಪಾರ್ಟ್ ಜೊತೆ ಇಲ್ಲಿ ಕ್ಲಬ್ ಮಾಡಕ್ ಬರಲ್ಲ. ಯಾಕೆ ಬರಲ್ಲ ಕೇಳಿದ್ರೆ ಒಮ್ಮೆ ಕ್ಲಬ್ ಮಾಡಿದ್ರಿ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಯು ಈಸ್ ಸೈನ್ ಎಕ್ಸ್ ಕಾಸ್ ಹೈಪರ್ಬೋಲಿಕ್ ವೈ ಪ್ಲಸ್ ಸಿ ಆಗುತ್ತೆ. ಆದ್ರೆ ಯು ಕೊಟ್ಬಿಟ್ಟಿದೆ ಅಲ್ಲಿ, ಯು ಇಸ್ ಗಿವನ್ ಟು ಬಿ ವಾಟ್, ಯು ಇಸ್ ಗಿವನ್ ಟು ಬಿ ಸೈನ್ ಎಕ್ಸ್ ಕಾಸ್ ಹೈಪರ್ಬೋಲಿಕ್ ವೈ ಅಂತ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋದ್ರಿಂದ ಅದು ಆಲ್ಟರ್ ಆಗೋ ಹಾಗಿಲ್ಲ, ಅದು ಇವನೇ ಇರಬೇಕಾಗುತ್ತೆ. ಅದರಿಂದ ಅದಕ್ಕೆ ಸಿ ಸೇರಿಸೋ ಹಾಗಿಲ್ಲ. ದೇರ್ ಫೋರ್ ಯು ಕ್ಯಾನ್ ರೈಟ್ ದಿಸ್ ಆಸ್ ಸೈನ್ ಎಕ್ಸ್ ಕಾಸ್ ಹೈಪರ್ಬೋಲಿಕ್ ವೈ plus I into cos x sin hyperbolic y plus c. Therefore, this is of the form u plus iv. What is the imaginary part? Imaginary part sikkidega. What is the imaginary part? V. V is cos x sin hyperbolic y plus c. So, therefore, analytic function is what? Analytic function is actually sin z. Sin z plus constant ideyala. This is analytic function. And what is the imaginary part? Imaginary part is cos x sin hyperbolic y plus C. So, do you have any doubts? Do you have any doubts? ಯಾರಾದರೂ ಒಬ್ರು ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಹೇಳಿ. Indudar, do you have any doubt?
No, sir.
Okay, right. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ?
ಹಾ ಸರ್.
Okay, right. ಈ ತರ ಪ್ರಾಬ್ಲಮ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ, ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಲೆಟ್ us go to the third problem. What is the third problem? Third problem is given real part is x square minus y square. You have to find the imaginary part and also analytic function. Let f of z equals u plus iv be analytic. So therefore, u is what? It is given to be x square minus v square. Real part is u. It is given. It is x square minus y square. Next, partially differentiate u with respect to x. You will get 2x. Partially differentiation of u with respect to y is minus 2y. Next, f dash of z is delta u by delta x plus I into delta v by delta x. But you can replace delta v by delta x by minus delta u by delta y using CR equations. So substitute for delta u by delta x and also delta u by delta y. This becomes 2x minus 2i into 2y. For Milne-Thomson method, put x equals z and y equals 0. So f dash of z is 2z, y is 0. Therefore, it is 2z. F dash of z is 2z. Next, integrate both sides. Integration of z is what? So it is z square by 2. 2z in a different integration, 2z square by 2. 2 cancel out. You will get z square plus constant of integration. But what is z? X plus iy whole square plus constant. But if you expand this x plus iy whole square using a plus b whole square formula, x square minus y square plus 2ixy plus constant can be written as I into c. And again regrouping this, x square minus y square plus I into 2xy plus c. So it is of the form u plus iv here. Therefore, our u is the real part x square minus y square. Imaginary part v is 2xy plus c. So imaginary part is 2xy plus c and the real part is given, that is x square minus y square. Function is, analytic function is what? F of z equals z square plus constant. Because in the beginning of the problem, what was asked is find the analytic function and also its imaginary part. So analytic function is what? Z square plus constant and imaginary part is 2xy plus c. ಇಲ್ಲಿ Milne-Thomson method ಯೂಸ್ ಮಾಡ್ದೇನೆ ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ಬೋದಾ ಸುಹಾಸಿನಿ? Milne-Thomson ಮೆಥಡ್ ಯೂಸ್ ಮಾಡ್ದೇನೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದಾ?
ಅನಾಲಿಟಿಕ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬಹುದು.
ಇಲ್ಲ ನೋಡಿ, ಅಲ್ಲಿ f dash of z ಎಷ್ಟು ಬಂದಿದೆ?
2x minus 2i 2y.
2 ಕಾಮನ್ ತೆಗೆದುಬಿಡಿ.
ಎಕ್ಸ್ ಮೈನಸ್ ಐ ವೈ ಬರುತ್ತೆ ಸರ್.
ಎಕ್ಸ್ ಮೈನಸ್ ಐ ವೈ.
ಐ ವೈ
ಎಸ್, ಎಕ್ಸ್ ಮೈನಸ್ ಐ ವೈ ಬರುತ್ತೆ. 2 ಇಂಟು ಎಕ್ಸ್ ಮೈನಸ್ ಐ ವೈ. ನ್ಯೂಮರೇಟರನ್ನು ಎಕ್ಸ್ ಪ್ಲಸ್ ಐ ವೈ ಇಂದ ಗುಣಿಸಿ, ಡಿನಾಮಿನೇಟರ್ನು ಎಕ್ಸ್ ಪ್ಲಸ್ ಐ ವೈ ಇಂದ ಗುಣಿಸಿ, ಆಮೇಲೆ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿ ಬರುತ್ತೆ. ಆವಾಗಲೂ ಬರುತ್ತೆ. ಅದರಿಂದ ಮಿಲ್ನೆ ಥಾಮ್ಸನ್ ಮೆಥಡ್ ಈ ಪ್ರಾಬ್ಲಮೇ ಬೇಕು ಅಂತೇನಿಲ್ಲ. ಓಕೆ, ನೋಡೋಣ ನೆಕ್ಸ್ಟ್. ಲೆಟ್ us go to the next problem. Find the analytic function whose imaginary part is given, hence find the real part. ನೋಡಿ, ಇದರಲ್ಲಿ ಅನಾಲಿಟಿಕ್ ಫಂಕ್ಷನ್ ಕಂಡುಹಿಡಿಯಬೇಕು. ಏನು ಕೊಟ್ಟಿದೆ, ಅದರ ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಇಸ್ ಗಿವನ್. ಹಾಗಿದ್ರೆ ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಕಂಡುಹಿಡಿದಾದ್ಮೇಲೆ ಏನು ಮಾಡಬೇಕು? ಹೆನ್ಸ್ ಫೈಂಡ್ ದಿ ರಿಯಲ್ ಪಾರ್ಟ್. ಅದರ ರಿಯಲ್ ಪಾರ್ಟ್ ಕೂಡ ಕಂಡುಹಿಡಿಯಬೇಕು. ಸೊ ಲೆಟ್ us take cos x cos hyperbolic y. So let f of z equals u plus I be analytic. ಇದರಲ್ಲಿ ರಿಯಲ್ ಪಾರ್ಟ್ ಕೊಟ್ಟಿಲ್ಲ, ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಕೊಟ್ಟಿದೆ. ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಆಫ್ u plus I v is v. Therefore v is given. It is cos x cos hyperbolic y. Find delta v by delta x. Delta v by delta x is minus sin x cos hyperbolic y. Minus sin x cos hyperbolic y. Next, delta v by delta y is ಇದರ differentiation with respect to y ಮಾಡಬೇಕಲ್ವಾ? Cos hyperbolic y differentiation ಏನು? Sin hyperbolic y. Cos x is constant. So we get cos x sin hyperbolic y. F dash of z is delta u by delta x plus I into delta v by delta x. ಆದ್ರೆ ನಮಗೆ ಮೇಲ್ಗಡೆ ಎರಡೂ ಪಾರ್ಷಿಯಲ್ ಡೆರಿವೇಟಿವ್ಸ್ ಯಾವುದರಲ್ಲಿದೆ? ಡೆಲ್ಟಾ ವಿ ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್, ಡೆಲ್ಟಾ ವಿ ಬೈ ಡೆಲ್ಟಾ ವೈ ಅಲ್ಲಿರೋದ್ರಿಂದ ಇಲ್ಲಿರೋ ಯು ಹೋಗಬೇಕು. ಯಾವ್ದು ಹೋಗಬೇಕು? ಡೆಲ್ಟಾ ಯು ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಅನ್ನೋದು ಹೋಗಬೇಕು. ಅದಕ್ಕೆ ನಾನು ಸಿ ಆರ್ ಇಕ್ವೇಶನ್ ಯೂಸ್ ಮಾಡಬೇಕು. ಇನ್ ದಿ ಸಿ ಆರ್ ಇಕ್ವೇಶನ್, ಡೆಲ್ಟಾ ಯು ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಅಂದ್ರೆ ಡೆಲ್ಟಾ ವಿ ಬೈ ಡೆಲ್ಟಾ ವೈ. ದಿಸ್ ಈಸ್ ಯೂಸಿಂಗ್ ಸಿ ಆರ್ ಇಕ್ವೇಶನ್. ಸೊ ವಿಲ್ ಗೆಟ್ ಡೆಲ್ಟಾ ವಿ ಬೈ ಡೆಲ್ಟಾ ವೈ ಪ್ಲಸ್ ಐ ಇಂಟು ಡೆಲ್ಟಾ ವಿ ಬೈ ಡೆಲ್ಟಾ ಎಕ್ಸ್. ಯಾಕೆ ಇದನ್ನು ವಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅಂದರೆ, ನಮಗೆ ಪಾರ್ಷಿಯಲ್ ಡೆರಿವೇಟಿವ್ ಎಲ್ಲ ವಿನಲ್ಲೇ ಬಂದಿದ್ದರಿಂದ ಇದು ವಿಗೆ ಬರೋ ಹಾಗೆ ಸಿ ಆರ್ ಇಕ್ವೇಶನ್ ಯೂಸ್ ಮಾಡಬೇಕು. ಹಿಂದೇನಾಗಿತ್ತು ನೋಡಿ, ಪಾರ್ಷಿಯಲ್ ಡೆರಿವೇಟಿವ್ ಎಲ್ಲ ಯುನಲ್ಲಿತ್ತು ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ. ಆದ್ದರಿಂದ ಇದು ಯುಗೆ ಬರಬೇಕು ಅಂದ್ರೆ ಅದಕ್ಕೂ ಸಿ ಆರ್ ಇಕ್ವೇಶನ್ ಯೂಸ್ ಮಾಡಬೇಕು. ಎರಡು ಯುನಲ್ಲೇ ಇರಬೇಕು. ಸೇಮ್ ಪ್ರಿನ್ಸಿಪಲ್ ಹಿಯರ್ ಆಲ್ಸೋ. ಸೊ ದೇರ್ ಫಾರ್ ಡೆಲ್ಟಾ ವಿ ಬೈ ಡೆಲ್ಟಾ ವೈ ಪ್ಲಸ್ ಐ ಇಂಟು ಡೆಲ್ಟಾ ವಿ ಬೈ ಡೆಲ್ಟಾ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ದಿ ವ್ಯಾಲ್ಯೂಸ್. What is delta v by delta y? This is cos x sin hyperbolic y plus I into delta v by delta x is minus sin x cos hyperbolic y. Next, by Milne-Thomson method, put x equals z and y equals 0. If you put x equals z, this becomes cos z sin hyperbolic 0 minus I into sin z cos hyperbolic 0 because y is 0. Remember, sin hyperbolic 0 is 0. Cos hyperbolic 0 is 1. Therefore, you will get minus I sin z. Now you have to integrate both sides with respect to that. If you integrate, you will get f of z. F dash z integration ಮಾಡಿದಾಗ, integration of the differentiation of the function is the function itself. Adrinda, you will get f of z equals I into differentiation of sin z is what? Minus cos z. Already all minus is there. Therefore, it becomes I cos z ಪ್ಲಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಈಗ ನೀವು ಬಹಳ ಕೇರ್ಫುಲ್ ಇರಬೇಕು, ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನು ಎಲ್ಲಿ ಸೇರಿಸಬೇಕು ಅಂತ. ಈಗ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ರಿಯಲ್ ಪಾರ್ಟ್ ಜೊತೆ ಸೇರಿಸಬೇಕು. ಈ ಕೇಸಲ್ಲಿ, ಈ ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋ ಕೇಸಲ್ಲಿ ಯು ಹ್ಯಾವ್ ಟು ಗ್ರೂಪ್ ದಿ ಕಾನ್ಸ್ಟೆಂಟ್ ವಿತ್ ದಿ ರಿಯಲ್ ಪಾರ್ಟ್. ರಿಮೆಂಬರ್, ಯಾಕಂದ್ರೆ ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಆಲ್ಟರ್ ಆಗಬಾರ್ದು. ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಕೊಟ್ಟಿದೆಯಲ್ಲ ಅದೇ ಬರಬೇಕು, ಬಿಟ್ರೆ ಅದಕ್ಕೆ ಪ್ಲಸ್ ಅಂತ ಮತ್ತೊಂದು ಎಕ್ಸ್ಟ್ರಾ ಬರಬಾರ್ದು ಇದಕ್ಕೆ. ಸೊ ದೇರ್ ಫಾರ್ ಐ ಕಾಸ್ ಆಫ್ ಝಡ್ ಅಂದ್ರೇನು? ಎಕ್ಸ್ ಪ್ಲಸ್ ಐ ವೈ plus constant. So this is I into cos x, cos of a plus b formula is cos a cos b minus sin a sin b. So cos x cos I y minus sin x sin y plus constant. So it is I into cos x cos I y is cos hyperbolic y, sin I y is sin hyperbolic y, I sin hyperbolic y. Remember, sin I y is I sin hyperbolic y. You will get minus I into sin x into sin hyperbolic y ಪ್ಲಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಈಗ ಕಾನ್ಸ್ಟೆಂಟ್ ಗ್ರೂಪ್ ಮಾಡಬೇಕಾಗಿದೆ. ಸೈನ್ ಎಕ್ಸ್ ಕಾಸ್, ಇಲ್ಲಿ ಐ ಗುಣಿಸ್ಕೊಂಡ್ಬಿಡೋಣ. ಯಾಕಂದ್ರೆ ಇಲ್ಲೊಂದು ಐ ಇದೆ, ಈ ಕಡೆ ಒಂದು ಐ ಇರೋದ್ರಿಂದ ಒಂದೇ ಐ ಬರುವಾಗ ಮಾಡೋಣ. ಹೇಗೆ? ಐ ಇಂಟು ಐ ಸ್ಕ್ವೇರ್ ಅಂದರೆ -1 ಆಗಿ ಅದು ಪ್ಲಸ್ ಆಗಿಬಿಡುತ್ತೆ. ಸೈನ್ ಎಕ್ಸ್ ಸೈನ್ ಹೈಪರ್ಬೋಲಿಕ್ ವೈ ಇನ್ ಪ್ಲಸ್ ಐ ಕಾಸ್ ಎಕ್ಸ್ ಕಾಸ್ ಹೈಪರ್ಬೋಲಿಕ್ ವೈ ಪ್ಲಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಈಗ ರಿಯಲ್ ಪಾರ್ಟ್ ಜೊತೆ ಸಿ ಕ್ಲಬ್ ಮಾಡಿ. ಸಿ ಕ್ಲಬ್ ಮಾಡೋದಾದ್ರೆ ಐ ಬೇಕಿಲ್ಲ ಅಲ್ಲಿ, ಅದನ್ನ ಜಸ್ಟ್ ಸಿ ಅಂತ ಬರ್ಕೋಬಹುದು. ಸೊ sin x sin hyperbolic y plus I cos hyperbolic y plus c. sin x sin hyperbolic y plus c, ಆ c ನ i ಇಲ್ಲದೆ ಇರೋದ್ರಿಂದ ರಿಯಲ್ ಪಾರ್ಟ್ ಜೊತೆನೆ ಕ್ಲಬ್ ಮಾಡಿ ಪ್ಲಸ್ I ಇಂಟು cos x cos hyperbolic y. ಒಟ್ಟಿನಲ್ಲಿ ಏನು ಅಂದ್ರೆ ವಿ ವೇರಿ ಆಗ್ಬಹುದು, ವೇರಿ ಆಗಬಾರ್ದು. ಯಾಕೇಳಿ ವಿ ಏನ್ ಕೊಟ್ಟಿದೆ ಅಲ್ಲಿ cos x cos hyperbolic y ಅಂತ ವಿ ಕೊಟ್ಟಿದ್ರಿಂದ ಅದು ಹಾಗೆ ಉಳ್ಕೋಬೇಕು, ಬಿಟ್ಟು ಅದ್ರ ಜೊತೆ ಸಿ ಬೇರೆ ನಂಬರ್ ಯಾವುದು ಸೇರಬಾರ್ದು. ಸೊ therefore it is u plus iv. Therefore the analytic function is actually analytic function is what? Minus, that is which one? Analytic function is I cos z plus constant. I cos z plus constant. Real part is what? Sin x sin hyperbolic y plus c. And imaginary part is given cos x cos hyperbolic y. So the real part is sin x sin hyperbolic y plus c. That is the real part. Next, we have another problem, that is tan inverse of y by x. Actually, the log function in a imaginary part. Tan inverse of y by x ಅನ್ನೋದು log function in a imaginary part. ಅದನ್ನ ನಮಗೆ ಆನ್ಸರ್ ಲಾಗ್ ಅಲ್ಲಿ ಬರಬೇಕು, ನೋಡೋಣ ಬಂದಿದೆಯಾ ಅಂತ. Let f of z equals u plus iv be analytic. So v is tan inverse of y by x. Delta v by delta x ಮಾಡಿದಾಗ, so tan inverse in a differentiation 1 by 1 plus y square by x square. Differentiation of y by x partially with respect to x keeping y constant ಅಂದ್ರೆ y constant ಅಂದ್ರೆ y ಹಾಗೆ ಇಟ್ಕೋಬೇಕು. 1 by x differentiation ಮಾಡಬೇಕು. Differentiation of 1 by x is minus 1 by x square. ಇಲ್ಲಿ LCM ತಗೊಂಡ್ರೆ x square ನ್ಯೂಮರೇಟರ್ ಬರುತ್ತೆ ಕೊನೆಗೆ. ಆ x square ಕ್ಯಾನ್ಸಲ್ ಆಗಿ minus y by x square plus y square. This is delta v by delta x. Next, delta v by delta y ಆಗಬೇಕು, ಅದು ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಆಗ್ಬಿಟ್ಟಿದೆ, ಸರಿ ಮಾಡ್ಕೊಳ್ಳಿ. ಯಾವುದು? ದಿಸ್ ಒನ್, ಇದು ಡೆಲ್ಟಾ ವೈ ಆಗ್ಬೇಕಿದೆ. ದಿಸ್ ಶುಡ್ ಬಿ ಡೆಲ್ಟಾ ವೈ. ಸೊ 1 by 1 plus y square by x square. Differentiation of y by x with respect to x ಏನು, keeping with respect to y ಏನು, keeping x constant, you will get 1 by x because differentiation of y is 1, x constant adinda 1 by x ಹಾಗೆ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. So it is 1 by x. Take the LCM. LCM is x square. ಅದು ನ್ಯೂಮರೇಟರ್ ಬರುತ್ತೆ LCM ತಗೊಂಡಿದ್ದು. ಒಂದು x ಮಾತ್ರ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಒಂದು x ಅಲ್ಲಿ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. You will get x divided by x square plus y square. Now f dash of z is delta u by delta x plus I into delta v by delta x. ಎರಡು v ನಲ್ಲೇ ಬರೋ ಹಾಗೆ ಮಾಡ್ಕೋಬೇಕು ಇದನ್ನ, ಯಾಕಂದ್ರೆ ನಮಗೆ ಡೆರಿವೇಟಿವ್ಸ್ ಎರಡು v ನಲ್ಲೇ ಇರೋದ್ರಿಂದ. So to differentiate, you have to use CR equations. So delta u by delta x is delta v by delta y plus I into delta v by delta x. But what is delta v by delta y? Differentiation ಮಾಡಿರೋದು ಇಲ್ಲಿದೆ. X divided by x square plus y square plus I into delta v by delta x differentiation is minus y by x square plus y square. For Milne-Thomson method, put x equals z and y equals 0. You will get x ಗೆ z ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀರಾ, y ಗೆ 0 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ z by z ಸ್ಕ್ವೇರ್ ಆಯಿತು. ಇಲ್ಲಿ y ಗೆ 0 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ I into 0 ಅಂದರೆ ಅದು 0 ಆಯಿತು. You will get z by z square, that is 1 by z. Now you have to integrate both sides with respect to z. So if you integrate f dash of z, you will get f of z. Differentiation of integration of 1 by z is what? Log z. So it is log z plus constant. So f of z is log of z andre x plus iy plus constant. The expansion of log of x plus iy ನಿಮಗೆ ಹಿಂದೆ ಬಂದಿತ್ತು. log of x plus iy expansion ಏನು ಅಂತ ಹಿಂದೆ ಬರ್ಸಿದ್ದೆ ನೋಡಿ. half log of x square plus y square. ಇದು ನೆನಪಿಟ್ಟಿರ್ಬೇಕು ನೀವು, ಇಲ್ಲಾಂದ್ರೆ ಎಕ್ಸಾಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ಬಿಡುತ್ತೆ. log of x plus iy expansion ಇದೆಯಲ್ಲ, ಅದು half log of x square plus y square plus I into tan inverse of y by x ಅಂತ ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಬರ್ಸಿದ್ದೆ, ಪ್ಲಸ್ constant. ಈಗ this is half log of x square plus y square plus I tan inverse y by x. ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ c ಬರೆಯೋಣ, ಯಾಕೆಂದ್ರೆ ಅದನ್ನ ರಿಯಲ್ ಪಾರ್ಟ್ ಜೊತೆ ಕ್ಲಬ್ ಮಾಡೋಣ. ಸೊ half log of x square plus y square plus c plus I into tan inverse y by x. Therefore it is of the form u plus iv, imaginary part tan inverse y by x given. ಅದು ಇಲ್ಲಿಯೂ ಕೂಡ ಬರುತ್ತೆ ನೋಡಿ, v ಅಂದ್ರೆ tan inverse y by x. U andre yavadu? Real part. Real part andre yavadu? I illde illa. What is the term which is independent of I? That is half log of x square plus y square plus c. So this is the real part, half log of x square plus y square plus c. And the analytic function is what? Analytic function is log z plus constant. Log z plus constant. And another problem is that given the imaginary part v equal to x minus y divided by x square plus y square. Start with, let f of z equals u plus iv be analytic. Analytic ಅಂತ ತಗೊಳ್ಳೇಬೇಕು ಇಲ್ಲಿ. ಇದನ್ನು ಮರೆಯೋ ಆಗಿಲ್ಲ. ಯಾವುದು? f of z equals u plus iv be analytic. ಯಾಕೆ ಮರೆಯೋ ಆಗಿಲ್ಲ ಅಂದ್ರೆ, in the middle what we use is CR equation. ಇದು CR equation ಯೂಸ್ ಮಾಡ್ತಾರೆ. CR equation ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬಹುದು? If the function is analytic. If the function is analytic, then only it satisfies CR equations. CR equation use ಮಾಡೋದಾದ್ರೆ function analytic ಆಗಿದ್ರು ಮಾತ್ರ. ಆದ್ರಿಂದ you must start from a function f of z equals u plus iv be analytic. So given the imaginary part ಅಂದ್ರೆ v ಅಂದ್ರೆ imaginary part, it is equal to x minus 5 by x square plus y square. You have to differentiate v with respect to x, keeping y constant using quotient rule. So what is the quotient rule? X square plus y square into differentiation of x minus y with respect to x is 1 minus x minus y into differentiation of x square plus y square is 2x. Further divided by x square plus y square whole square. Simplify ಮಾಡಿದ್ರೆ you will get y square minus x square plus 2xy whole divided by x square plus y square whole square. Next, delta v by delta y is x square plus y square, again using quotient rule. You have to differentiate partially with respect to y, keeping x constant. X square plus y square, differentiation of x minus y with respect to y, keeping x constant. Constant under 0, x again. Minus y differentiation is minus 1. Minus numerator, that is x minus y, into differentiation of the denominator with respect to y, remember, keeping x constant. Therefore, x square differentiation is 0, y square differentiation is 2y, divided by, in the quotient rule, we have v square, that is x square plus y square whole square. So on simplification, it yields y square minus x square minus 2xy whole divided by x square plus y square whole square. Now f dash of z is delta u by delta x plus I into delta v by delta x. But if you use CR equation, delta u by delta x is delta v by delta y plus I into delta v by delta x. Substitute the value of delta v by delta x and delta v by delta y here, you will get this expression. Next, use Milne-Thomson method. Put x equals z, y equals 0. So y is 0 here, x is z, you will get minus z square, y is 0, y is 0, and z square square. So therefore minus z square by z raised to 4 plus I, y is 0, x is z square, it becomes minus z square plus y 0 ಆದ್ರಿಂದ ಈ term 0 ಆಗುತ್ತೆ. ಇಲ್ಲಿಯೂ y 0 ಆದ್ರಿಂದ z square square ಅಂದ್ರೆ z raised to 4. Simplify ಮಾಡೋಣ. Z square ಇದೆ, z raised to 4 ಇದೆ, it becomes minus 1 by z square minus I, ಇಲ್ಲಿ z square ಇದೆ, z raised to 4 ಇದೆ, z square cancel ಆಗುತ್ತೆ. You will get minus I into 1 by z square. ಈಗ ಮೈನಸ್ ಎರಡೂ ಟರ್ಮ್ ಇರೋದ್ರಿಂದ ಮೈನಸ್ ಆಚೆ ತೆಗೆದ್ರೆ ಆಮೇಲೆ 1 by z square ಕಾಮನ್ ಇದೆ. Therefore minus of 1 plus I into 1 by z square. This is the analytic function. Remember, this is f of z, which is analytic function. Next, okay, it's not analytic function because we have not integrated this. Now we have to integrate this. Integrate both sides with respect to z. So f of z equals minus of 1 plus I, constant adrinda hage ide. Integration of 1 by z square ideyala, ಅದನ್ನ actually z raised to minus 2 ಬರ್ಕೊಂಡು integrate ಮಾಡಬೇಕು. Z raised to minus 2 integrate ಮಾಡಿದ್ರೆ z raised to minus 2 plus 1 divided by minus 2 plus 1 ಅಂದ್ರೆ it is minus 1 by z. Remember, integration of 1 by z square ಹೇಗೆ integrate ಮಾಡೋದು? Z raised to minus 2 ಅಂತ ಬರ್ಕೊಂಡು z raised to minus 2 plus 1 divided by minus 2 plus 1 ಮಾಡಿದಾಗ you will get minus 1 by z plus constant. But what is our z? Z is x plus iy. So 1 plus I into 1 by x plus iy, because minus of minus it becomes plus here, plus constant. Further, denominator ಅಲ್ಲಿ x plus iy ಬಂದಿದೆ. ನಮಗೆ separate into real and imaginary parts ಬರಬೇಕು ಅಂದ್ರೆ ಕಾಂಜುಗೇಟ್ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಮಾತ್ರ i ನ್ಯೂಮರೇಟರ್ ಬರಕ್ಕೆ ಸಾಧ್ಯ. ಅದರಿಂದ i ಅನ್ನ ನ್ಯೂಮರೇಟರ್ ಬರುವಾಗ ಮಾಡ್ಕೋಬೇಕು x plus iy ಟರ್ಮ್ ಅನ್ನು. ಅದನ್ನ ಮಾಡೋದು ಹೇಗೆ? ಕಾಂಜುಗೇಟ್ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ. ವಾಟ್ ಇಸ್ ದಿ ಕಾಂಜುಗೇಟ್ ಆಫ್ x plus iy? x minus iy. Therefore, you have to multiply both the numerator and denominator by x minus iy. So you'll get x minus iy whole divided by x plus iy into x minus iy ಅಂತಾಗುತ್ತೆ. That is x square plus y square. Multiply ಮಾಡಿ ನೋಡಿ. It is x square plus y square plus constant. ಈಗ ಇದನ್ನು separate real and imaginary parts. ಇದನ್ನು separate ಮಾಡೋಣ. ಯಾಕೆ? i ಇರೋದನ್ನೇ ಒಂದ್ ಕಡೆ ಸೇರಿಸೋಣ, i ಇಲ್ದಿದ್ದನ್ನ ಮತ್ತೊಂದ್ ಕಡೆ ಸೇರಿಸೋಣ. So you will get x plus 1 into x minus iy by x square plus y square ಅಂದ್ರೆ x plus y by x square plus y square real part ಆಗುತ್ತೆ. i ಬಂದಿದ್ದನ್ನ ಈ ಕಡೆ ಗುಣಿಸೋಣ. i square ಅಂದ್ರೆ -1 ಆಗುತ್ತೆ. That becomes +1. ಇಲ್ಲೊಂದು ಮೈನಸ್ ಇರೋದ್ರಿಂದ plus i into x minus y divided by x square plus y square plus c. So real part ಜೊತೆ c ಸೇರಿಸಿ you will get x plus y by x square plus y square plus c plus I into x minus y by x square plus y square. This is the imaginary part given. X minus y by x square plus y square is there. This is the imaginary part given there. Therefore, you will get u plus iv. Therefore, u is the real part. Real part yavadu? X plus y by x square plus y square plus c. This is the real part. Imaginary part already given there. We need not have to mention that. And what is the function here? Function is minus of 1 plus I into minus 1 by z plus constant. So this is the analytic function. Given the imaginary part, you can find real part and also the analytic function. Okay, the time is ending now. I shall take up the remaining problems in the next class. Thank you. Do you have any doubts? Yes. Ashita D, do you have any doubt?
No, sir.
Okay, right. Thank you. So I can, I shall end this. I shall end this class now. Thank you.